Absolutely.
I'm just recording for the benefit of anybody, who might want to tune in it later. So let me share my screen. Morning, Smita. You're right, bang on time. Can you see my screen?
Yes, we can see.
Super. Okay, so let me quickly go over it. I mean,
Hey, good morning,
maybe four.
Kiran. Hi, Devyani.
Hey, morning, Smita.
Hi.
Looks like you are the only two guys, right? Rather ladies, right? Sorry, my bad. I guess we are already given two chances, so may not
Yeah,
be, um, fair to do it again. So anyway, we are recording the session, Smita. So I
yeah,
was
yeah, sure.
telling, Devyani that I've been doing a course on data science, right? More out of passion, right? Not that it's
Mm-hmm.
related. So and all of it is
Mm-hmm.
in Python. So that gives me a little bit of background on what's happening. Although this is all R is unknown territory for me, but still I thought maybe I'll take a shot at it because I did look at the problem statement, right? And maybe it is not clear if you don't have the right context. So the thought,
Okay,
Smita, was that we'll spend maybe 4 or 5 minutes on the some basic concepts which probably got missed in the class, and then we'll go into the
sure.
demo. Is that fine?
Yeah, yeah, yeah. Makes sense.
Okay.
Hi,
And Smita,
Jagan.
hi Jagan. Did you install the software by any chance? The R and R Studio?
No, yeah, not yet. But no,
Good
I'm.
morning, Jagan.
I have to do it today only. Good morning. Good
Yeah,
morning.
me too.
Super.
Hmm.
So
No, I did install. Yeah, I did.
okay. So what I was telling Devyani, Smita and Jagan, right, while we were getting started, was that we'll just touch upon maybe few minutes, right, on few basics, which probably got missed, right. And if you ask me what is my qualification to do that, just that I was doing some data science course more out of passion, not that it is related to my job, right, not that I require it. So I have some background on Python, although this is not the current topic. I think the data analytics is a subset of data science, right? So maybe I'll give it a shot, right? Let me know what is your feedback. So the goal is, as I mentioned, right, 3, 4, or max to max 5 minutes we'll spend in this fashion. So the first one, right, and data description, I think it was outlined in Lori's session. That is the only one step out of the 8 steps in EDA. EDA stands for exploratory data analysis, which is the first step towards any data science or data analytics problem. So we are only at the
Hmm.
first step, right? And what exactly I mean by this, let me probably draw and explain it. So when you open up a data set, right, and these days data run into TBs, right? Huge, massive data, right? Netflix will have TBs of data, right? You have essentially two kinds of data that is, you know, embedded within the SQL file or the Excel file, and that Excel file could be thousands of lines long, right? It could be massive files, right? Because you are talking about data which is a new oil. So you're talking about huge terabytes of data, so much of parsing which is involved. The old Excel analysis, anyway, it was limited, but then it can't even handle these large volumes of data. That's why we are leaning on to Python or R, right? Or Julia or some of these advanced programming languages to do data analysis. Because, a lot of the um, basic stuff is done by Excel, but Excel has a lot of limitations, right? So basically, these are the two types of data in any data set, right? One is the categorical data, which is the not the non-numerical data, right? You have characters, like it could be movie name, it could be distribution. All these are the same data type, which is categorical, right? But numeric data type is like budget or gross. This is essentially the movies data set. If you have seen anybody has seen this, right? All of this come under one data set, that is numeric. This is categorical, right? And these
Sure.
needs to be treated differently.
Mhm.
Now, what, from a standpoint of the multiple metrics that are used, there are so many plots which get used, but I would say the easiest to understand is box plot, right? So because it's very, very, very intuitive once you understand it, right? So coming to that, I'm not sure if you remember the old high school method. There is a Q1, Q3 are first quartile and third quartile. So basically 25% percentile of data, 25 percentile of data, right? And I don't know if you can see the mouse pointer just to make sure.
Yeah, it's
Yes, we
visible.
can see. We
Okay.
can see.
So this is essentially forms at 50% of the data, and that is also known as interquartile range, IQR, right? And there are these whiskers. These are called like the cat's whiskers, right? These are the 1.5 times away from the IQR, right? And this forms your bound for outliers. So this becomes very important when we this is the key data set that you will look at it any data, especially numerical data. Let me make that clear. Right? The numerical data is processed differently. The categorical data is analyzed differently. So I'm only talking about numerical data when I'm talking about the box plot and this specific analysis, right? So with that, and there are so many ways, right? I mean, to so many plots in Python, R, even Excel for that matter. So it becomes mind-boggling at times. But we'll only look at this right now. And another popular one, which I think Lori touched upon, was KD, or the sort of the Gaussian curve, right? That you would have seen. Even that is something that we see. I think that came up even in the high school math, right? Now the second part, again, I don't know if you had seen the LM commands that got mentioned, right? And LM stands for linear regression, right? And that is the most basic predictive model that one could think of, because it builds on your high school math again. That is nothing but y equal to mx plus c, right? So what it assumes is that there is a linear relationship between the dependent variable and the independent variable, right? Independent variable is nothing but your input, and dependent variable is something that depends on your input, which is the y, right? In this case, so you assume that there is a linear relationship. I mean, that is this model, right? When you apply the linear regression model, it assumes that there is a linear relationship, but obviously, right, it is not linear. Life is not linear, right? I mean, then everything is so easy, right? And all these deviations are called errors, and there are multiple methods to measure errors, right? R square, advanced R square, F statistic. There are so many jargons. So I will not really get into that, because all of it requires a class by itself, right? And these are some other conditions that are required if you were to apply linear regression model.
Linear regression model, Kiran, just one people like me who are completely out of touch of statistics or no basics of this. I'll get through that. What is the linear regression? How to use that, how the applications of that. But no, this is basically required for using this, right?
Yeah, no, this is, as I mentioned, right? It was referenced in the class, right? Although it was not discussed, it was mentioned in the commands which was sent out. That is why I'm touching on that model. And again, there are so many models like SVM, K-means, and even the neural network models, right? CNN and so on. So those are way more complex. But this is the easiest model to understand, right? And just to make sure it's clear, X is one variable, right? Like that, even a traditional linear regression model has several variables. So it will be x1, x2. Sorry, my the mouse doesn't allow me to write in a good handwriting. So
no problem.
So there are x1, x2, x3 up to xn. So it doesn't really mean that y equal to mx plus 3, or the linear model only has one variable. There are so many variables, but then the relationship is, yeah. Does that answer your question?
Yeah, that's fine. Got it. So you are saying this is one of the model, and there are multiple models to use this for the basics of data. Okay.
Yeah, and when you say prediction, we are talking about AML, right? And linear regression, as the word indicates, right? It's linear. There is no complexity. There is no square relationship. There is no cubic relationship. There is no if and else condition. It's a plain math y equal to mx plus c, right? A straight line relationship. Although there are errors, right, which needs to be modeled and all that stuff, right? So in the sense, if the errors are progressing in a certain fashion, right, that is essentially what homoscedasticity means, right? Then you can apply linear regression model. Even if the errors are small, there is a the errors are spread in a separate in a certain fashion, then you can distribute or map the data set to a linear regression model. So yeah, so basically there are a lot of limitations, but most intuitive to understand. So that's why people often refer to this. And in some cases, especially version to version testing, some QR testing, linear regressions becomes the plan of choice, because you're testing new version of a tool versus the old tool, right? So it is a sort of a linear regression fits well in those scenarios. But in today's world, right, we are talking about 5G, so much of data, right? I mean, talking to each other, linear regression really doesn't work. I mean, in AML, whether it is inference or in the edge scenario, right? The next topic I wanted to introduce, again, these are just very basic introductions, right? Which is at best we can do. And again, it is touched upon because there was a reference in the commands which is sent out, right? So basically what one needs to understand, right? I think this is again high school math. When we, I don't know if you remember, there was a C value, right? We had to look up, there was a printout that we used to take, right? And then there was a C value which was given. And then we should compute P value and see where it lies. I don't know if you remember. This is all something that we did in high school math, right? Okay. So in case if you don't remember from the context of this class, right, or in the session, or the key thing that you need to understand is there is a significant value, right? And typically that value is 0.05, right, or 5%. And if it is less than 0.05, then we reject null hypothesis, right? There is something called null hypothesis, right? So null hypothesis assumes, so, and just to add, there are two areas, right, that is of interest. This is a significant area, that is 95% of your data, and there is a 5% of data that lies outside it, right? So and if it lies outside, then basically you hypothesis is nothing but a equation, right? You assume certain things. It could be as simple as saying that an IPL, let's say Mumbai Indians, when they play home matches, they have an advantage, and that can be your null hypothesis. And the alternate hypothesis is that there is no home advantage, right? So how they test it is that, again, there are multiple transforms which are used. The C value is the basic transform. There is something called a T test, which is what was applied in our in the class, right? Again, it was not discussed in the class. It was sent out in the commands which was mentioned, right? So T test is like, think of it for simplicity, think of it like Z value, right? You are using a different transform, but ultimately you need to compute the P value, check whether it is less than 0.05 or not, right? And if it is lower, then we reject. If it is higher, then it means that it lies in this area, the dominant area, and hence you accept the null hypothesis. So this is again very basic. I'm not getting into details, right? It is coming up in the specific use case. That is why I'm sort of touching upon it, right?
One more thing, Kiran, you were mentioning about the IPL, that Mumbai, the matches are happening. Mumbai, it is null hypothesis, right?
Yeah.
So I didn't get that point, but if you know, this is a basics of that, then I will probably go through this. What I have to refresh on all the subjects completely to be very.
Yeah. Well,
I
let me
spend
try
some
to
time
give a.
and do
Yeah.
some reading,
Maybe
and
let
then
me give,
if there is any doubt,
sorry,
I'll ask. No, once I go through that, if I have to understand something before getting into that, I will go through that and then get in touch with you for if there is any clarifications or anything is needed for that.
Yeah, no, I think it's a very interesting case study, right? Maybe let's get to it separately, right? I mean, because the data set that I have right now on R is on the movies, right? So
Sure.
maybe, so basically you're having an assumption, and the idea is to test the assumption, whether it is right or wrong, and then reject or select the hypothesis, right? So that's all that there is to it. In the process, you use a transform, you use different kinds of tests, and there is a p value which is nothing but the probability, right? And depending on the value where it lies, you select or reject the hypothesis, right? So now coming to the R installation, right? Since we're getting into the demo part, these are the two steps that you need to follow. If you're setting it up for Windows, there are similar processes for Linux or Mac. So all you need to do is, you need to go to this link, install R, then install R Studio. R is, Studio is nothing but the interface, right? It's like, think of it like the GUI, but R engine is required for running the Studio. So since we don't want to come to slides again, I'll just summarize what will be touched upon, right? I mean, the basics we touched upon. The key aspect which is covered, right? I mean, and again, is that correlation doesn't mean causation, right? And it's a very common statistic philosophy. it may be, you know, it may
Correct.
it's not easy to explain it, but then yeah, you see so many references, right? But and people sometimes even us, right? Even in elections, even in work life, we mix correlation with causation, and then we take decisions, right? Everyone
Correct.
included, right? So that is something that, as per statistics, we should avoid, right? And the last comment was, again, there are so many things we could talk about, but the outliers should always be removed from the analysis, right? Outliers could be studied on its own to see what it entails, but from a if you are making a generic statement, generic analysis, we should avoid it. Otherwise, it can skew up the entire data analysis and it can lead to false prediction.
Correct, I agree. Actually, I had a live situation yesterday on this. We were doing some forecast for this quarter, what is happening, type of it. So, as is an IT services business, so headcount into number of average salary and all those stuff. Yesterday, I suddenly saw the average salary was substantially high. I went into the details with people and then saw that there are outliers there. That is actually causing the mean to be very high, and that gave a wrong picture for the future also. So I was just thinking of that outlier need to be same point was there, need to be removed.
What is said is absolutely right, and it's a common scenario that is actually ongoing, especially in the tech space, right? I mean, every domain can probably, there are differences, industry there are dependencies, but in tech space now the salaries are not making sense, right? Some of these salaries are sometimes even higher than US salaries, right?
Correct.
So it's really crazy, right? Sometimes, I think I should have stuck. Should I continue with the tech, right? Looking at the current market scenario. So coming to the R Studio, right? I've just opened it up. There are four parts, right? One essentially is the area where you keep your script, right? Second is the console, right? Where you see the results of your run. The third is essentially it shows where your data set, what sort of data set you have, right? What are you creating, etc. Right? And the last one essentially is the plots. It'll help you view the plots, etc. So these are the basic, works from a workspace management standpoint. These are the basic elements, right, that you have in a R Studio. Let me clear all this. So let me start, right, with the data set. How many actually are seen this data set, new movie data set?
Yeah, I have.
Okay, sure, good.
This data set is taken from our example there. They have given.
Yeah, correct. I mean, there are so many data sets available, Jagan. Actually, I mean, that's a beauty, right? I mean, if you look at any of these open source communities, there are so many data sets, much more complex, right? These are actually a very less number of entries. If you look at only 200 odd entries, right? But real data sets, real world problems are normally run into thousands, sometimes, millions of lines, right? So because data is huge these days, right? Whatever you get. But from the purposes, right, of this specific data set, let's look at what it is, right? So let's look at, you have options to magnify and view and stuff like that, right? You can open it up, by the way, in an Excel sheet. So it's not that I'm not preferring that. So you have movie name, you have a distributor, right, whose name is mentioned, like Paramount, right, or a Buena Vista. You have numerical data up in here, which is the budget, your gross, right, which is essentially the worldwide gross that
revenue.
And then year in which potentially it was released. ROI, that which is return on investment, right? Anybody worth their salt investing their monies, right? We need to know how much is the ROI, right? And not surprisingly, there are a lot of negative ROIs, right? We know that movie industry, like airline industry, people also burn their monies, right? Quite a bit.
Correct.
And there is something called BV, which I mean, again, none of this was even I had to do analysis to figure out what it is, right? But BV, if anybody has a guess, you can feel free to take a shot at it. But it is dependent on some of these the variables that is mentioned here, right? Any guesses?
Book value or budget, budget variance or something.
Okay, it's actually far simpler than that, right? With Jagan is, I think, thinking more complex terms. So distributor Buena Vista, right? If you look at it, wherever that is present, you're seeing a variable which is 1. If it is not Buena Vista, then it is 0. You can see this.
Oh,
Oh,
okay.
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 Yeah. So again, it
Yeah.
is not explicitly told, but I just analyzed the data. Then I realized that wherever there is a Buena Vista, there is BV. This variable, it's most likely we will, right, as data analysis folks, right, we will create such variables. Right? A data scientist will create a lot of such features, artificially create such features to do analysis, right? So in this case, it is hand cooked. It was already created and given to us on a platter, right? There are so many commands, and there are so many packages which could be installed onto RStudio, right? Which I will probably not get into. But let's look at the basics, right? What is there? So let's run these commands. So there is a run option here. You attach movies.
Command is also given by them.
So
Sorry?
Kiran,
Yeah.
just for a
Command is
sake of
given by
everybody, once we have the Excel sheet, we import the data sheet, right? Here
Mhm.
from the
Yeah.
right hand window.
So there
Is
is an
that
option here,
okay?
right?
Yeah.
There is an option called
Yeah.
import dataset.
Okay.
So
Okay.
and you can do it in this fashion. You can open it as a Excel file. There are multiple options, right? So there is an import data set even here.
Absolutely.
There's an open file option here, right? So you can, it's not like you have to do it only using this option, but I typically use this option, import data set,
Okay.
because it works for me, right? You can import from Excel. There are so many other formats as well which are supported.
Okay. Got it.
And then you can import it right here, right? From so for instance, movies is my key data set. I've created some other data sets in between, right? Like numeric is my own data set that I created.
Okay.
So with the from interest of time, right, I will not get into semantics. Just understand these are the things that you need to do, right? Just follow it, right? Think of it like you're putting this into a black box and then you get it, right? Because if you get into semantics of programming, then it is not a discussion we can close in few minutes, right? So
Yes.
do names of movies. You will get the column names, right? The various attribute names which are out there in the data set. This is useful when your data set is humongous, right? You have probably 100 columns, right? This is very simple data set, but in other cases, you may need to do that. Another option is summary.
What was that? Can you repeat, Kiran? This was
Names, right? Once you load a data set, in this case, it is movies, correct? You can print out the column names by using a command called names. So think of that, you import the data set, just use names. Within the brackets, you input the data set. So
okay.
So, I'm just trying to say, don't get into semantics, right? Don't try to compare it with C or C++, Java, right? Then going forward, it will be slightly tricky. From the interest of time standpoint, right? So if you do summary, it prints out the summary of the entire data. So it will tell there is something called movie. There are 227 movies which are mentioned, but the class mode, everything is character, right? And the budget as well, right? This is the minimum budget. This probably is in millions. I'm assuming it's a Hollywood data, right? So it's minimum of 2.8 million. That is the budget. Maximum of 300 million, right? Median of 45 million, right? That's about budget. Likewise, you can look at world gross, year, ROI, and stuff like that. So all the metrics you can look at. So ROI you can see, right? The minimum is actually minus 0.9, which is actually pretty lousy, right? If you are a producer, you wouldn't want to go for a film or with a distributor or any partnership for that matter, right? Because nowadays all these agreements are signed upfront. So if you are somebody who is putting in hard-earned monies, or if you're a VC, you would still want to see what is the ROI on the money that you're investing. And my understanding of this, again, the problem statement was not well defined, but my understanding, because they created a category variable BV, is that we should check if Buena, if you were to invest in Buena Vista, right, distribution or the pictures of Buena Vista, it could be that you're representing Buena Vista, or it could be that you're looking at it from a producer. Was there a question? Sorry. Sorry, did somebody have a question?
No,
No,
Kiran,
no.
I don't think there was any
Okay,
question.
I thought I heard a noise in the background.
Yeah.
Yeah. So the idea is whether it is worth their, what is the ROI in going with Bina Vista? Maybe somebody is looking to acquire Bina Vista, or maybe somebody, some finance CFO, right, of Bina Vista is analyzing, are they doing better than other distributors, right? So they are trying to infer, Bina Vista in the context of other distributors, right, in the US who are distributing Hollywood movies, right? So now we did this, right? We did the summary. We can also do this in select variables. We just do summary on select variables. So I'm doing summary only on budget, ROI, world gross. So I mean, there are so many combinations. So think of it now, instead within the movies, you are selecting certain columns: budget, ROI, C, world gross, right? Now C is, this is how R uses it. I will not get into array and then different data types and all that, because then it gets into a different discussion, right? But think of it that you use C brackets. Maybe in a different programming language it could have been a simple array, right? Python, it is more intuitive, but R, you expect it to be given in this fashion, correct? Movies, C bracket, and then you give the column names that you want to give. Okay. Another thing that the statisticians, right, or data scientists often look at is correlation. So what correlation means is, but the same variable obviously correlates with the same variable, right? It's a one correlation, right? By the way, correlation ranges from -1 to 1, right? When you look at it. Now, world gross and budget, there is a 0.78 correlation. Actually, that's a very good number. In the, while by itself, it's not a, you can't draw a, inference. So there is a 10-minute, I think we have to wind up. I have used my personal Zoom login. I prefer not to use my corporate login, right? Because these days all the data that we use is anyway, right, with company, with everyone, right? So due to ethical reasons, I'm not using it. So we have to wrap up in, I think, next 10 minutes. So just a time check, right? Quick time check. So so what this means is that ROI and budget, there is a negative correlation. So higher budget means probably lesser ROI. That's an interesting thing, right? Intuitively, sometimes you may think, yeah, more budget, higher budget movies could make more money, but that's not the case. But higher budget movies is likely to have a higher world gross. So that there is a positive correlation, but negative correlation here, right? So I mean, just to give an example, right? A Marvel movie or some Disney, some of the flagship Disney movies, because there is a cult fan following, their budgets could be very high, right? And their returns also might be very, very high. But then you can't use that and then say that, hey, that one number could skew up your entire analysis if you take an average, right? Or a statistic variable, even sometimes median, right? So that is why we need to look into the details. So now if you were to look at a small sample set, right? I mean, I'm creating a new sample set. You can all create. The keyword here is subset, and movies, you select some variables, right? This is, in the prior case, we just did summary on few variables. Here I am creating a new data set, right? Which is a subset of the movie data set. So that is why you see there is only 4 variable. I don't know if you can see this, right? New mark it for you.
You can see, yeah.
So if you see this one, this has only these 3 variables, right? Which essentially, these are things we can do, right? I mean, you can do multiple hand-holding on the data, right? Just to make sure you are you're only looking at what you want, right? Sometimes you look at sideways and then see something else and then you get distracted. And this is again pertinent when there is a huge volume of data. Likewise, I can create different variables, right, with conditions, right, and stuff like that. So it's up to you. I mean, now you can again do a summary on the select sample set. That is another option. You can do a correlation on the sample set. I think I probably have to give numeric one because the other one has categorical data. So this one, if you only want to do correlation, right, you don't have to go and correlate each variable. You can just correlate on the data set, which is a subset, right, in this case. And here, please note, I am looking at not huge ROIs. Like the Marvel movies I was talking about, I'm not taking those outliers, right? I'm looking at a smaller ROI. And I'll get to the reason as to why I took 10 and all that, so that that becomes easy. Now let's see what is Buena Vista in the context of overall distributors, right? So there are 114 movies which are where distribution channel is via Buena Vista, and let's see how many movies are there in this particular data set which are not distributed by Buena Vista. That is essentially 113. So roughly 50%, right? Buena Vista 50%, Paramount Pictures, right? Now this is a plot which I love, right? I mean, I love it because it gives you all the data in very once you understand it, then it becomes very easy, right? To look at the overall data. Let me just try this. Oh, sorry. So can you see this? I don't know if it's visible enough.
Yes, we can see.
Yeah.
Yeah.
So
Yes.
again, this is actually fantastic if you ask me, right? Because it tells you few key things. This line is the median of Buena Vista. This line is the median of Paramount Pictures, right? This is the Q1 or the 25 percentile on Buena Vista. This is the Q3 on Buena Vista. This is your Q3 on Paramount, Q1 on Paramount, right? If you look at all these figures, Buena Vista beat all these numbers fairly hands down. Even the interquartile range, right? I mean, the cat whiskers that you see, these areas, right? These are actually way higher than Paramount Pictures. But you have one massive outlier, right? Now, maybe we need to look at this data set and see, there could be one massive movie, right, which Paramount Pictures released in this time duration, which resulted probably in a very high cumulative return, right? Now, if you look at this number 10, ROI of 10, why did I look at this number? It is around the cat's whiskers, right, of Buena Vista. So I am not really bothered about too much of outlays, right? Because if I keep looking, that will come one in 100, maybe 1 in 1,000. So I should not be looking at these data points, right? So because it will skew my data. So if you see, there is some clustering happening here as well, right? Outside the data, outside the cat's whisker or outside the interquartile range that we are interested in, right? Here also there are, but there aren't as many outliers, right? Look at the difference, right? From here to here, it's massive if you look at it. So this is one picture, or one plot I would like you to look at. Again, my personal preference, but entirely up to you. There are so many such plots, right? There is KD.
Kiran, in this, where it is shown that it is an outlier, because 7 variables are there because of that.
I am only looking right now at ROI, right? The only metric that I'm looking at is ROI, nothing else. ROI is nothing but it's a synthesized form of worldwide gross budget and everything, right? So, so maybe we'll just do the quick math on it so that you're absolutely clear. Let's probably do that. Right? Okay, so let's look at the data set again. If you look at it, let me take a simple example. So here in this case, the worldwide gross is 0.5. So 0.5 million minus 8 million is minus 0.75 million roughly, right? So that is the money they actually lost, and minus 0.75 by 8 is minus 0.93 roughly. I mean, I'm not doing an exact math here. So it is nothing but worldwide gross minus budget by budget. So in this case, Paramount Pictures, so you get the point, right? You invest some money, you look at what is the total output, and then compute your ROI.
Sure.
So I'm absolutely at the edge, right? So let me just dive into the test part we were talking about. There, see, the fave stats is one of my favorite. I don't use summary, right? I mean, since I started, getting into R last week, I found favorite stats to be much more user friendly than summary. It gives you standard deviation also. Summary doesn't give you standard deviation, right? There are multiple commands and stuff like that. So, but let's get into this. Hypothesis test, right? So this is again a big topic. let's try to give a quickly look at it, right? So when we do this BV versus non-BV, right? That is Buena Vista versus non-Buena Vista. We are trying to do a Buena Vista, and in this case Paramount, right? You are trying to see what is the mean ROI of Buena Vista, and you are trying to compare with Paramount Pictures ROI, right? And in this case, if you remember, what did I tell you about null hypothesis and p-value? I don't know if anybody remembers. So we looked at it and said, okay, let me, in case if I have forgotten, let's look at it. Let me just read.
It is around 5%, and like remaining most of the common things are around 95%. That's what.
Correct. So thanks for reminding, right? But so I'm not going to bring up the slide again. Anyway, it's available to you, right? I'll share the recording. So what Smita mentioned is absolutely right. You look at the significant value, and if P is lower than the significant value, right? In this case, typically it is 0.05. Then you reject the null hypothesis. Else, if it is higher, in this case, it's higher or lower?
This is like higher.
It's higher.
Correct. So if it is higher,
higher,
then
higher.
you reject, right? So basically, you know, if you look at it, the you accept the null hypothesis, you reject the alternative hypothesis, right? Alternative hypothesis says that there's a true difference. That there is a real difference. So between Buena Vista and Paramount. So it is, you have to dig deeper into what are the semantics, right? And when we look into the means of these categories,